Future of Coding, Automation with AI Generative Models. So Debanjana is here with us. Let's welcome her with a big round of applause, everybody. Over to you, Debanjana.
Hello, everyone, and good afternoon. Won't keep you waiting for the lunch too long, so let's get started. I am a quick intro. I am a research engineer at IBM Research India. I work in the AI Ops team. So the topic that I'll be discussing today is something that is very close to my heart, and I hope all of you enjoy it. Uh, we'll keep the questions for the end, and let's get on with the presentation first. Right. So I think all of you know the topic of the masterclass today. And basically, coding nowadays is no more a solo effort, right? It's like a dynamic collaboration between software developers and intelligent AI models, right? So in this class today, we want to discuss how this shift is happening, what are the key technologies behind it, and it's 45 minutes, so we can't really get into the depths of it, but I'd like to give a holistic, high-level overview of the entire space. So this is how we'll get going today. A bit of intro, then we'll look at the foundations of the technologies at the AI encoding space. We, after that, would like to look at some state-of-the-art models that are playing key roles in the industry right now, followed by which we would look at some challenges, some ethical considerations that, because whenever AI is in play, we need to think of ethics, right? So challenges and ethical considerations would be a topic of discussion for today. And finally, we'll be concluding with the future landscapes in this space, of course. Transforming how we code one model at a time. By the way, I'm audible, right? Yeah, thanks. So if we go back to our school days, right, we would write small snippets of Java, small snippets of Python. We would use normal notepad or text editors, right? We still do sometimes if you're lazy, but yeah, text editors would be the thing. We would compile and we would run it. But then came IDEs, integrated development environments, right? So that helped. That was a good change, right? We would have auto-completions happening. I think the first IDE that I used for Java would be something called Eclipse. I don't know how if you are aware of it, yeah. So now with Python, I think a lot of you are aware of VS Code. It's pretty popular among Python developers. And even with AI assisted coding, we still use, a lot of us, VS Code, we still use it. But AI models are coming into play. And that is what we'll be talking about today, right? So GitHub Copilot is one of the, a very famous example of AI-assisted coding. So a quick question, has any of you used GitHub Copilot here? Right? So you must be knowing, right? Like if you have some error in the code, it would actually prompt you, okay, this is what you need to write to change the code script, get it running. So that is a huge shift from text editors, which is a simple notepad, to a place where you're writing a code and automatically the bug is getting detected and you're being prompted as to what needs to be changed. So that is the entire shift that we have seen so far. So foundations of AI-driven coding. So we'll be understanding some of the key technologies that drive the foundations of AI-driven coding. And needless to say, generative LLMs or large language models are the key technology that we need to understand here. So the two questions that we need to know today are, what are generative AI models and how does it work in coding? Right. So I won't go through the bookish definition of Gen AI models. I think most of us would know, like models, neural networks, you give mostly transformer-based, or rather completely transformer-based, I would say. And you have a query or a prompt, and it gets encoded, and then from the decoder you get the output. A lot of these models, a lot of these Gen AI models, they can include the entire transformer, or they could be the only encoder based, only decoder based, or encoder decoder based, right? So, do you know some encoder based Gen AI models, audience? So the BERT family, code BERT, these models would be the encoder based models, right? What about the decoder based? Decoder based, all of you know. One of you, quickly. You're using it all the time. Chat GPT. Yeah. GPT, all the GPT clan of models, right? GPT clan of models or the Llama clan of models would be the decoder based Gen AI models. And when we come to encoder decoder based models, that would be the T5 clan of models. If you've heard of T5, T5 plus, MT5, these are all the encoder decoder based models. And we also BART models, if you've heard of. So those would be the, so every bit of transformer could be utilized and could be used to build a Gen AI model. Right. Okay. Transformers, not Optimus Prime. So I think we've already discussed about transformer. If any of you have read the original transformer paper that was published by Google back in 2019, then yes, right. So that would be this. This is the famous diagram, right? That whenever we talk about transformers, pops up. So I would not get very into details of this, but this part would be the encoder part on the left-hand side, and on the right-hand side you would have the decoder part. So the left-hand side you have the inputs coming in, getting converted into numerical representations, concatenated with positional encoding, and then these n number of blocks. So when you hear of 12-layer BERT, right, that would essentially mean there are 12 such blocks, 12 encoder blocks. So each of these blocks would contain of a multi-head attention block, followed by addition normalization, feed forward, addition normalization again. So this entire thing would be your encoder block. And from here, the encoder block would feed its output into the decoder block. There are two inputs to the decoder block, this, and this would be the previous time step output of the decoder. So these two things would get inside the decoder block. Again, n number of times, n number of layers you can have. And these are the different, if you want a deeper, I would suggest you can go through G. Alamar's blog. It's really good if you want to really understand the details of these blocks. And ultimately, we have the linear layer softmax, which would give us the output probabilities that would map to our desired output, right? So just a quick overview of what exactly is there in the background that encodes, decodes, and gives you the output. Because all the time what we are doing is we are opening ChatGPT, prompting, and we're getting the results. Very easy. But what is there behind, right? So it's important to know that. Right. So recent advances in AI for coding, we are moving gears to what are the key star players, or what are the state-of-the-art models that are there out in the market, and what is transforming the space of AI in code. So Meta has launched Code Llama, if you are aware of it. And all of these, most of them have papers. So if you want to know deeper about it, I would suggest just note down the names and you can just read the papers if you want to have a deeper understanding on exactly what is the architecture and how it works. Code Llama would be mostly built on the Llama architecture, but it is trained on a huge, huge corpus of code. So most of these models are a power play of how much data you have. If you know, like GPT-2, GPT-3, the major difference is the corpus of data, right? So that is there. Right. The next one would be Microsoft Research, having Code Fusion. So they use something called diffusion models to create their LLM, curate their model, their solution for code generation and context-aware coding models. Then we have DeepMind, Google DeepMind, with AlphaCode Extended. So there's AlphaCode, and then this is AlphaCode Extended. And I think the key takeaway from this paper would be that they use retrieval-based systems along with the LLM capabilities. So they are using these two to create a optimal solution. Right. So I just had a little bit of a comparison chart with different key players or key state-of-the-art models that are there. So Code Llama we just spoke about. Then we have DeepSeek Coder. DeepSeek Coder. Okay, sorry. The retrieval one that I was talking about, sorry, I make that correction. That was about the DeepSeek Coder one, not the Alpha Coder. But in DeepSeek Coder, that is what we do. We have the retrieve, it's a beautiful merger of IR and NLP. So we have retrieval systems and we integrate that with the generative LLMs. And so I'm from IBM, so a little bit biased towards the things that we have. So Granite models have been recently released. So we have some models which are completely trained on code. So Granite code instruct models would be those models, and it's trained over like 12 trillion tokens and covers around 116 programming languages, which is huge. And it's all based on GPT Neo X architecture. And I have a chart which basically shows that there are different code related tasks, and it's either at par or beating most of the state of the art models right now. So this is what I was talking about. So if you look at this chart, we have uh, we have the just base models on the top and the instruct models at the bottom, and the blue one over here is the Granite 8B code base, right? And the others are Mistral, Llama, Gemma, Star Coder, Code Llama, and Code Gemma, right? And it's trained on and tested on human eval pack. It's also trained on MBPP. These are common data sets, benchmark data sets that are used in this space. And it's these results are over 6 programming languages, namely JavaScript, Java, Go, C++, Rust, and Python. So in case you want to have, if once you go back and you want to dabble around with it, I have the QR code. You can scan and check out the GitHub repository for Granite models. So I'll just pause for 2 seconds, and if you want to pinpoint where the error is happening. So that part I think gets very nicely handled. I mean, I'm seeing every day when we are working with that, very nicely handled with AI models, agentic models, so to say. So job reduction, maybe to some extent. I'm saying it's not there yet that it'll take over the entire space. Very junior level roles, yes, it might be impacted, but otherwise it's more of a collaborative effort. Assistance, that is what AI is there for. Research based roles hiring is a bit different. So coding rounds are there, sure, but what we look at is understanding of like how well they can think, or uh, they may not know certain technologies. We don't expect them to know everything, especially if they are freshers. But math problems, for example, that tests the aptitude, like whether they can quickly solve something. Problem solving, those things are tested. And if they're writing something, like this is something I a bit personal also, if they're writing something on their CV, they should know it through and through. I will not throw around jargons just for the sake of it. If I'm saying I know transformers, I will know what is query vector, I will know what is key vector, I will know everything. I'll know how attention works. So that is the expectation. Yes, yes, that can happen. So be wary of this. The prompt has a certain length. So if you're giving large, huge prompts, it may not read the entire thing. It's probably because there's a token length. It's probably 10224. It's probably 512. It'll just look at that bit, and the rest will be. So in that case, your output will not be relevant, right? So, and if it's again too complicated, so ultimately these models, they depend on prompts, how good your prompts are, right? So if your prompt is too complicated, uh, it might not give you the desired result. So that is there. So I think one way is when you have these kind of chat kind of things, right? Like in ChatGPT, you post something small, it gives you the answer you have a follow-up question, it gives you. And like because it has a memory, so it retains some of the information, not very far off maybe, but say 5 conversations or 5 utterances above. It will retain that, and so I think in that space, that's why agentic models I was saying, right? In React and all, it can be interactive, so that will be helpful. Right, right. Yeah, I think back and forth helps, but as I've been mentioning over and over again, I think we are not yet there. More, at least in my personal experience, and in fact, I showed them with examples as well. The codes are not always doesn't make sense, so, and that's why you need to know what happens in the background. I, just the other day, I was trying to create a very small UI demo we needed for to show something very basic. So I thought, let me prompt ChatGPT. Let's see what it gives, but it didn't run. So I had to go back, read the docs, understand, and then I had to do. So that's why. Definitely so, because see, data structures algorithms is basics of computer science that you can never do away with, right? But if you see nowadays, even in school curriculums, they have AI, which at least at my time we won't even think about it. So basics of ML, because I think everybody in some way, in some analytics, something they're using some part of AI. So to have some very not very complex, some basic understanding, I think it makes sense. Surely. Mm-hmm.
But I have like 10 full stack developers in my team.
Correct.
Right? Like one of the challenges, like how do I make them an AI engineer too, along with being full stack developers? They're not always like UX developers or like UI developers, but we still have to use those models directly or indirectly, right?
Right.
We use like GitHub Copilot and all.
Mm-hmm.
Now, how do you? I mean, like, is there any like with IBM or like with your use case? Have you done anything like where? How can you train your full stack developers to know AI ML more than just knowing, right? Like in depth.
In depth, so then they have to take courses, right? I mean, they just can't these are assistants. Again, I'm very I'm harboring on the word assistants. They are not complete solutions. They will give you a skeletal idea. They can very likely hallucinate, because they will give you a plausible looking code. And if your full stack developers just use that code to that will not work. So they will need to have some basic knowledge, some basic courses they can take up, so that at least they can understand that, okay, in this, because although it will not probably be gibberish, like in some cases I have had to probably change 2-3 lines, and that the code got working, but I need to know what line to change exactly, where is the code going wrong. So I think that it's not magic. You have to have some knowledge at least.
Yeah, the reason is right. Most of us talk about the token limit, everything, right? We call embeddings and all. Beyond that, if I ask like what is a vector here, right? What dimension it says, like most of us wouldn't be knowing, because they are not traditional AI
Absolutely.
engineers, right? Like so that is where like some of the challenge that would come.
They would not need to know the embedding dimension, so to say, if they're using it for some real-time application. As I said, kids are using it as black boxes, right? So for using it as black box, that much knowledge also, if they understand, that's okay. If you want to get into the depths, I think then that embedding space and all that matters.
Thank you.
Thank you. Okay, I think we are out of time. Thank you, everybody.
Thank you, Debanjana. Thank you, everybody. Just something that I wanted to share. Apart from all the technical knowledge that Debanjana has, I think it's good to know that she's a very good, and she's a trained Bharatanatyam dancer as well. Yeah, so I mean, I'm no one to even talk about the technical, the skills, the knowledge that she has spoken about here. You guys are in sync with her. So I hope you all enjoyed the session.